This video is called Confidence Interval for Mean Sigma Known. There will be another video called Confidence Interval for Mean Sigma Unknown. And before we start, let me just remind you, this Greek letter is called sigma, and it stands for Population Standard Deviation. Let's go through this introduction. The first thing is to look at page 5 of my outline. So here you see a piece of page 5 of my outline. This piece is the chapter 7 part. Page 5 also covers chapter 6 and chapter 8. And this is a complete overview of what goes on in chapter 7. It's divided into proportions, means, and standard deviations, confidence intervals for each of those things. Over here you find out how to solve problems on the calculator for each of those things. And over here you find the relevant formulas for everything you have to do in chapter 7. So if you haven't printed out my outline yet, do it. Keep this handy. Refer to this as you're listening to this video, and it will be very helpful in helping you keep your perspective, I think, keep your context straight. Okay, so we're back here at the introduction. Remember, and before I get into this, before you watch this video, please watch the video called Confidence Intervals Introduction, because that lays a lot of the groundwork for what I'm going to be talking about here. It will be difficult to follow this if you haven't watched that video first. So it says here, remember, and that means assuming you've looked at that first video. When you construct a confidence interval, you are using information from a sample to estimate something about the population that the sample came from. When you construct a confidence interval for a mean, you are using the sample mean, and the symbol for that is x bar, to estimate the population mean, and the symbol for that is mu. To do this, the calculator will take the sample mean, x bar, and it will add and subtract the margin of error. It will actually create two numbers. With one number, it will add the margin of error to the sample mean, and for the other number, it will take the sample mean and subtract the margin of error, so we'll get two numbers. And those numbers will give it an estimated range of values for the population mean. And again, the symbol for the population is mu. The population mean is mu. So that range of values is called an interval. So what does a confidence interval for mean look like? Remember, we said the calculator will take the sample mean, or x bar, and add and subtract the margin of error to get an estimated range of values for the population mean, or mu. We can express this in a couple of different ways. Here's the first way right here. Mu, again, that's the population mean, equals, and what we're really doing is estimating mu here. We're saying it equals x bar plus or minus e, and e is the symbol for the margin of error. So this means you're really creating two numbers. One number is x bar plus e, and the other number is x bar minus e. And this says that mu is somewhere in the range of those two numbers. The other way we write exactly the same thing is this way. Mu is between. When you have these symbols like this, you're saying that this is between what's here and what's here. And again, we have x bar minus e on the low end of the interval, and x bar plus e on the high end of the interval. So this is basically telling the same story that this is. Again, the title of this video is Constructing a Confidence Interval for a Mean Where Sigma is Known. Well, what does that mean, sigma is known? Look at this. This is really important, so get it straight. It's not a request. You got to get this straight. Every problem, you see that's in red, every problem that asks you to construct a confidence interval for a mean will give you a standard deviation. And then I say here, read the statement again. It's so important. Every problem that asks you to construct a confidence interval for a mean will give you a standard deviation. That standard deviation will be either the standard deviation of the sample, and the symbol for this is S, or it will be the standard deviation of the population, And the symbol for that is this Greek letter, which we call sigma. So when we say sigma is known, we mean that the problem gives us the standard deviation of the population. These kinds of problems are the subject of this video. There will be a separate video covering how to construct a confidence interval for a mean where sigma is unknown. And by the way, all this stuff about sigma is known, sigma is unknown is only for mean problems. You may have seen the video on constructing a confidence interval for a proportion. Sigma has nothing to do with confidence intervals for proportions. There's just one kind of that problem. With means, there's two kinds. Well, now that we know that we have to find out if sigma is known, how do we do that? How do we read the problem and decide if we know sigma? Well, we're going to go through some examples here and see how we do that. And these examples are all taken from the Triola textbook in Chapter 7. So here's a problem. A simple random sample of 40 salaries of NCAA football coaches has a mean of $415,953. Assume that sigma equals $463,364. Okay, in this problem, is sigma known? Yes. It's obvious because they tell you that sigma, and there it is right there, equals this amount of money. We know that that is sigma, which is the standard deviation of the population. But also, whenever a problem tells you to assume, you see this word assume right here? Whenever a problem tells you to assume that the standard deviation is some value, that will always be the population standard deviation. Here's another example. A simple random sample of 50 adults is obtained, and each person's red blood cell count is measured. The sample mean is 4.63. The population standard deviation for red blood cell counts is 0.54. Is sigma known? Yes. It's obvious because in this case they actually use the phrase population standard deviation. So we know the population standard deviation, which we call sigma. So sigma is known in this problem. Here's another example. I'm down here now. A simple random sample of 125 SAT scores has a mean of 1522. Assume that SAT scores have a standard deviation of 333. Is sigma known? Yes, but in this case it's not as obvious as in the first two cases. But there are two things that tell us this is the population standard deviation, or sigma. First, you see the word assume, and we talked about that above. But second, it says SAT scores have a standard deviation of 333. This statement that I quoted right here, this statement is not limited to the sample. It is a general statement about SAT scores. So whenever you see a general statement like this, that means they are talking about the population. So sigma is known. Here's another example. A simple random sample of birth weights in the United States has a mean of 3,433 grams. The standard deviation of all birth weights is 495 grams. Is sigma known? Yes, sigma is known. The word all, which I've highlighted here, tells us they are talking about a population, so that the standard deviation is the population standard deviation, or sigma. Again, whenever you see all, that means they're talking about the population and not about the sample. Here's our last example. In a test of the Atkins weight loss program, 40 individuals participated in a randomized trial with overweight adults. After 12 months, the mean weight loss was found to be 2.1 pounds with a standard deviation of 4.8 pounds. Is sigma known? In this case, no, sigma is not known. We are given a standard deviation. I really want you to notice this. There is a standard deviation. But we should be able to see that this sentence that talks about the standard deviation is talking about the sample. Okay, the sample is described up here. And then they say what the results of the sample study were. So this whole sentence is about the sample. So the standard deviation they're giving us is the sample standard deviation, not the population standard deviation. So in this case, sigma is unknown. Very important. that you recognize the difference between this problem, this example, and the other examples we did above. Okay, I think we're ready to do some problems. Problem 1, and this should look familiar. A simple random sample of 40 salaries of NCAA football coaches has a mean of $415,953. Assume that sigma equals $463,364. And this problem is from the Triola text, page 341, exercise 22. So there are really two things they're asking us to do here. A says find the best point estimate of the mean salary of all NCAA football coaches. And B says construct a 95% confidence interval estimate of the mean salary of an NCAA football coach. So just notice the difference between these two problems. This says find the best point estimate, and this one says construct a confidence interval. So I just want you to recognize that's two different things you're doing. So question A, we're just going to address question A right now, and it won't take long. This is easy. The best point estimate of the mean, it is always simply the sample mean, which in this case is $415,953. So the best point estimate is the sample mean. We could write X bar in there, is this amount of money. That's it. It's as simple as that. The rest of this discussion will address question B. So the first thing we have to do is understand the problem. Do you see the word sample? That's right here. That means that what is coming next is information about the sample. Now, do you see the words construct a 95% confidence interval estimate? There they are. I've highlighted them in yellow. That tells you this is a confidence interval problem. And there could be other problems that are set up very similarly, but they don't ask you to construct a confidence interval. They ask you to do something else. So you have to focus on these words. They're very specific, and they tell you exactly what you're going to be doing. Let's look at the third bullet down here. See the word mean. Where is the word mean? It's right there. It's also here. So you see that word mean a couple of times. That tells you that this is a mean problem and not, for example, a proportion problem, because you have confidence interval problems that are for proportions, you have confidence interval problems that are for means, and you've got to know which one you're looking at. And the problem tells you. The problem tells you. And finally here, do you see the words sigma equals 463,364? That means, and we talked about this before, that sigma is known, which means we know the standard deviation of the population, and that tells us we're going to use a particular approach to solve this problem. We'll get to that soon. The next thing is to write down the sample statistics. Now we can't see the problem anymore, but hopefully you remember what it said. The first bullet says, see the sentence, a simple random sample of 40 salaries of NCAA football coaches has a mean of $415,953. That tells us about the sample. So that we're going to get our information from this. For a mean problem, the sample statistics that we need are n and x bar. We also need either the sample standard deviation, which is s, or the population standard deviation, which is sigma. So this stuff is true of all problems where we're constructing a confidence interval for a mean. Well, let's see how this applies to our problem. N says we need n and we need x bar. N is the number of subjects in the sample. In this case, it's 40. The sample mean is given as $415,953. So x bar is that amount, $415,953. So there's our n and there's our x bar. But now we also have to find this standard deviation. Sigma is given as $463,364. So now we have the three things we need in order for the calculator to do this problem for us. We have n, we have x bar, and we have sigma. So now we are going to use the calculator to construct the confidence interval for us. We're just going to follow these steps right here. The first thing says go to stat tests z interval. We use z when sigma is known. So we're finally getting to the punchline on this. What difference does it make whether sigma is known or unknown? The difference is when sigma is known, we use this calculator function called z interval. So I'm going to repeat that. When sigma is known, we use z. So let's go do that on the calculator over here. We're going to stat. We're going to scroll over to tests. And now we're looking for z interval. So we're going to go down here. You see here, by the way, you see z test. That's not z interval. That's a different thing. But here you see z interval down here. So we're going to scroll down to z interval and hit enter. And the first thing we see under z interval is input, data or stats. Well, these things here are statistics. They're not data. Data would be is if we had all 40 coaches' salaries and we put them into a list and we're working with that. That would be data. But in this case, somebody else has done that and they found our mean and standard deviation for us. So we are using stats. So we are going to come over here and get off of data and go on to stats and hit the enter key. So it looks just like this. Now the first thing it wants from us is sigma. Well, sigma, if you'll remember, was 463,364. So we're going to go down to sigma and put those numbers in there. 463,364. Then we're going down to x bar and putting this in there. 415,953. And we're going down to n. N is 40, so we're just going to type in 40. The confidence level, and the problem tells you, it will say construct a 90% or a 95% or a 99% confidence level. In this case, it said 95%. So our C level, our confidence level is 0.95. So we're going to go on down to calculate and hit enter. And it very quickly gives us our answer. What you're looking at right here, this is the confidence interval. And I've just typed it up here. The calculator answer is this. This is the small number, and this is the big number. If we want to answer this in words, and sometimes your online homework or your professor in an exam will say, how do you describe your answer in words, or words to that effect? And we could say here, we are 95% confident, that comes from the confidence level, that the true population mean of the salary of an NCAA football coach is between these two numbers that came, again, right off of the calculator. So if you were answering this question online, if you put those numbers in there, you'd be done. You would be done constructing the confidence interval. But I want you to understand where these numbers come from, so they're not just like they came from a black hole. So this section here is called understanding the confidence interval. So if you remember before, I told you one way to structure the confidence interval is to say, for a mean, is to say that mu is between x bar minus e on the low end and x bar plus e on the high end. Well, we know what x bar is. That came right from the problem. That's the sample mean. So for my first step here, I'm just going to start plugging things in. I can plug in the sample mean. 415,953, it goes there, and it also goes there. And I'm leaving the rest the way it is. But notice, this is the best point estimate. So whenever you're doing a mean problem, whenever they ask you for the best point estimate, it is simply x bar. So there it is. Now, we need to get E. There's two ways to get E. There is a shortcut way, which I'm going to do. That's the first way I'm going to do it. But there's also a way using a formula, which is how the calculator does it. But I want you to see how easy it is to sort of back into E once the calculator has given you the confidence interval. So here you see this E equals. It looks a lot worse than it is. E is simply the high end of the confidence interval, which in this case, you see right here, the high end is 559,548. That goes here, minus the low end of the confidence interval, and that we got right from this, this is what the calculator gave us. These numbers are the same up here. 272,358. So that goes in the numerator and you divide by 2. And if you work that out, you get 143,595. So that's the margin of error. And that's actually dollars. So we would say $143,595. So that is the margin of error. And again, we found it the shortcut way. We backed into it. And the fact that the calculator had found the confidence interval for us allowed us to back into the margin of error. So whenever you're doing online homework, if it asks you for E or if it asks you for the margin of error, this is the easiest way to do it. First get the confidence interval and then back into it by using this simple formula. So now that we have E, we can fill in everything on our original confidence interval structure. Here's X bar. So that's your X bar. Here's E, which we found, again, using the shortcut. And here we subtract X bar minus E. Here's X bar again. Here's E again, and this time we're adding. So if you take this number and subtract this number, you will get this number. And if you take this number and add this number, you will get this number. So that's how the confidence interval works. Well, let's see where this margin of error came from. In other words, how the calculator calculated the margin of error. Above, we saw the shortcut way to find the margin of error. Again, you take the big number in the interval and subtract the little number, and then you divide by 2. It's that easy. But there is a formula for E, and again, that's what the calculator uses to construct the confidence interval. For a mean problem where sigma is known, remember that's the subject of this whole video, where sigma is known, the formula for E is this. E equals Z alpha over 2, and this is called a critical value, times sigma over the square root of n. In this problem, the margin of error works out like this. In other words, the value we substitute for these things. I'm going to talk about the critical value in a minute, but let me go to these things first. Sigma is easy. The problem gave it to us. 463,364. The square root of n is easy. The problem told us that n is 40. So that's the easy part. The tricky part is this thing called the critical value, or Z alpha over 2. That works out in this case to 1.95996. I'm not going to go into a lot of detail in this presentation about how to find that. If you look in my outline on page 6, it tells you how to find a whole bunch of critical values, including Z critical values. This alpha over 2 tells us that there are 2 tails. So again, if you look at my outline, you'll find out how to find a Z critical value when you have a 2-tail test. And if you simply follow the steps in your calculator using second Var's inverse norm, you can find out what Z alpha over 2 is. I hope to do another video in which I talk just about how to find the different kinds of critical values. I touch on this a little bit in my video called Normal Probabilities, Finding Critical Values and Percentiles, but I don't really talk about this finding this specific kind of critical value. In any case, when you work out this formula, you get this number 143,595 for E, and that was the same number we got when we used the shortcut approach that I talked about earlier. Okay, here's another problem. This problem is called finding minimum sample size. And I want to emphasize, we're still in Chapter 7, but in this case, they're not asking us to construct a confidence interval. It's so important that you learn how to read these problems and what they're asking you to do. If it were asking you to construct a confidence interval, it would have to say, construct a confidence interval. And this problem doesn't say that. This problem asks a question that says, how many? So when you're in Chapter 7 and you see a question that says, how many, that means it is a minimum sample size question. And it's very important that you keep those two things straight. A minimum sample size question could also simply say, find the minimum sample size. And then it's real obvious what they want you to do. But it might also simply say, how many? And the way you think about these questions is, imagine you're in the business of conducting surveys. and somebody comes to you and they say they want you to conduct a survey for them. Well, one of the first things you have to decide is how many subjects are going to be in your survey? How many people do you have to talk to? And that's what we're going to find out here. The answer to that question, how big does your sample have to be, depends on the requirements of your client. And we'll see how that works in a minute. But here's the question. How many adults must be randomly selected to estimate the mean FICO score of working adults in the United States? FICO is a credit rating. We want 95% confidence that the sample mean is within 3 points of the population mean. And the population standard deviation is 68. And this again is from the Triola textbook. So our first step is to understand the problem. You see these words, how many? Now I'm repeating myself. That means that this is a minimum sample size problem. It is not asking you to construct a confidence interval like the previous problem. In these problems, we are solving for n, which is the sample size. Now, do you see the word mean? I have it highlighted as well. That means you're being asked to find a minimum sample size for a mean and not for a proportion or percentage. Because you can get minimum sample size questions for proportion problems. But this is a minimum sample size question for a mean problem, and you solve them differently. So it's very important that you keep that straight. Now we're going to write down what I call the specified variables. The confidence level. You see here it says we want 95% confidence, so the confidence level is 0.95. Now the margin of error, we need to write that down. Whenever you see the word within in a minimum sample size question, whatever comes next is the margin of error. You see this word within right here? There it is. Whatever comes next is the margin of error. In this case, it's 3. So there you go. It's 3 points. The population standard deviation they're giving us is 68. There it is. So those are the variables you need in order to solve this problem. So we're going to solve this problem two ways, one with a calculator and one by hand. Let's see what it says here. If you come see me, I can transfer a program from my calculator to yours that makes it very easy to solve these types of problems. So let's assume you've got that program. And by the way, I haven't figured out how to put that program onto this online calculator, so I don't have the programs in this calculator. So if you have my programs, the way you'll do this problem is you will hit the program button, which I can point out to you right here. You would click on that button. And then you would go down, you'd scroll down until you saw a program called nmean. You would hit the enter button twice, and then it would prompt you for these three things. It would prompt you for the interval, which really means the confidence level. So you would type in 0.95. It would prompt you for sigma, and you would type in 68 for that. It would prompt you for the error, and you would just type in 3. So even though the problem said 3 points, that does not mean 3 percentage points. So for a mean problem, the margin of error is almost always a whole number. So you would just put in 3 there. And you would hit enter after doing all those, and your answer would come back immediately. N equals 1,974. That means your sample has to contain at least that many subjects in order to meet the requirements, the 95% confidence level and the margin of error. So that's how you would do it on the calculator, and I'm sorry I can't demonstrate it on this calculator here. But again, if you want that, come see me. I will transfer that program from my calculator into yours. You can also do this by hand. Remember, when we do a minimum sample size problem, we are solving for n. The basic formula for n in a mean problem is this, and this is also in my outline. N equals all of this stuff squared, and this is z alpha over 2. This is coming up again. This is a critical value times sigma, and we know what sigma is, over the margin of error, and we know what the margin of error is. The margin of error is 3. Sigma is 68. So again, the only thing that's tricky is finding the critical value. So if you look at my outline, page 6, it will walk you through how to find a critical z value for a two-tailed test. And if you do that, you will find that the critical z value is 1.96. And then sigma is 68, margin of error is 3. So we have all this squared. So step by step I'm doing that here. This 1.96 times 68 is 133.28, and that's over 3. Then we do the 133.28 divided by 3, and we get this, which we then square. And you get this number. And the rounding rule for minimum sample size questions is you always round up. So in this case, because this is 0.7, we would round up anyway. But even if it was 0.1, you always round up in a minimum sample size question. So the answer here is 1,974, which is the same answer that you would get if you had the program in your calculator. And that is the end of this rather lengthy presentation.